of extending the range of distances over which we feel familiar, over which we feel we understand the laws of nature, both to very large distances and very small distances. I'm going to talk a little bit about the history of this effort, going back over many centuries, and then bring the story up to the present and describe how today the same scientists who are concerned with nature at the very smallest scales that we can examine are also concerned to understand the universe at the very largest scales that are accessible to us. Before the beginnings of science, the range of distances over which people felt familiar was very restricted. You can't really clearly see any distance smaller than about a millimeter. And most people would never travel farther from their homes than a few hundred kilometers. From a millimeter to 100 kilometers is a factor of about 100 million. And it was within that range that men and women lived their lives. The scale of distances began to expand with the beginnings of something similar to modern science in the period we know as the Hellenistic, from starting with the death of Alexander the Great and Aristotle around 300 BC. In Alexandria, Eratosthenes worked out the size of the earth. From the appearance of the shadows of a vertical pole at noon at the summer solstice, both at Alexandria and at Aswan near the Tropic of Cancer, he was able to work out that the circumference of the earth is about 50 times the distance from Alexandria to Aswan. It was not a bad estimate. We know today that the circumference of the earth is 47.9 times the distance from Alexandria to close to Aswan, the Tropic of Cancer. A little earlier, Aristarchus of Samos had developed a clever mathematical method for estimating the sizes and distances of the sun and moon in terms of the size of the earth. From the appearance of the moon and sun during lunar and solar eclipses, and from the angle between the sun and moon when the moon was half full. His method was mathematically perfect. He understood this as well as any modern scientist. His measurements were terrible. They were grossly inadequate. And in fact, there was no way that anyone at that time or for centuries afterwards could have done much better. Aristarchus estimated that the distance of the sun from the earth is between 135 and 517 times the diameter of the earth. And of course, it's much larger than that. We know today that it's about 12,000 times larger. It wasn't measured accurately, however, because it's a difficult measurement, until 1672, when Cassini worked out the scales of distances of everything in the solar system. The next step was to measure the distance from our solar system to the nearest star. Now, it was known that could be done if one could observe a phenomenon known as parallax. That is, the apparent shift in position of one star relative to another as we observe the sky 6 months apart from opposite sides of the Earth's orbit. Because observing from different sides of the Earth's orbit, we look at the stars at slightly different angles. This is an extremely difficult measurement because parallax